to go to the moon and do the other thing, not because they are easy, but because they are hard.
Moon's South Pole has become the ultimate destination for space agencies around the world. From its treasure trove of invaluable resources like water ice and potentially helium-3, to its unique geological landscape that promises groundbreaking scientific discoveries, the lunar South Pole is a hotspot of opportunity. It's not just about planting a flag, it's about the immense scientific and economic benefits that could shape the future of space exploration and even life back on Earth. Last week, India made history by becoming the fourth nation to successfully land a robotic probe on the Moon, and it achieved another milestone by being the first country to do so near the lunar South Pole.
I'm glad India did not land in the same place everybody else has landed on the Moon. You don't want to redo what someone else has done and already been verified. You want to do something new. You chose a place where no one has landed before, and that's the South Polar region of the Moon.
India's Chandrayaan-3 mission adds a new layer of intrigue to questions about the Moon's formation. Understanding the Moon's origins requires using what we know about the Moon, our knowledge of its mass, orbit, and the precise analysis of lunar rock samples, and coming up with scenarios that could lead to what we see today. The prevailing scientific theory about the formation of the Moon is the giant impact hypothesis, which suggests that the Moon was formed from the debris left over after a massive collision between Earth and a Mars-sized body named Theia.
Evidence suggests, and all theoretical understanding of the formation of the Moon, helped, by the way, by rocks we brought back by the Apollo program, and we get a sense of the origin of that place, that the Moon doesn't have much iron in it. And an object that size should have much more iron in it than it does. So how do you make a whole object that has hardly any iron? So you make it out of a collision with Earth, but it sideswipes Earth after Earth has already sunk its iron to its core. The Earth was molten, heavy stuff falls to the middle, light stuff floats to the top. Compared to iron, rocks are light, so all the rocks floated and the iron sunk. Iron, nickel, gold, cadmium, all the heavy elements, they're down there in the core. Okay, so now Earth has pre-sifted the elements. Pre-sifted. Now you have a Mars-sized impactor that sideswipes the Earth, scattering Earth's crust into a ring around the Earth. That Mars-sized impactor keeps going, but the debris mess that it left continues to orbit the Earth. And the slightly larger bits of this have more gravity than the slightly smaller bits, so they'll attract more objects and they get bigger. And as they get bigger, they have even more gravity and they get even bigger, and it's a runaway exponential growth.
For eons, the Moon has been a beacon of wonder, casting its glow upon the tapestry of human history. It has been the muse behind countless myths, legends, and artistic endeavors that span civilizations. This celestial body, shimmering in the night sky, has not just inspired tales of fantasy, but has also been a silent observer of Earth's transformative journey. In the boundless theater of the cosmos, the Moon stands out as our closest celestial confidant. Its stark landscape, untouched by the veil of an atmosphere, serves as a pure canvas, chronicling the remnants of cosmic events. Every crater, ridge, and expanse on its surface whispers tales of meteoric impacts, volcanic eruptions, and the shifting of tectonic plates. As our species relentlessly pursues knowledge, the lunar South Pole beckons as a treasure trove of scientific wonders. Tyson, with his characteristic blend of passion and expertise, suggests that by delving into the Moon's intricate geology, we unlock secrets of Earth's nascent days and the formidable forces that sculpted our solar system. But to truly appreciate the enigma of the lunar South Pole, one must navigate the intricate dance between the Sun, Earth, and Moon.
I've done this experiment. I asked people, where's the sun at 12 noon? More than half the cases, they point straight up. What's odd is it means they've never looked. Because for the entire continental United States, at no time of day and no day of the year, the sun is ever directly overhead. Maybe at noon, the shadows go away. It just means modern people just not observant. There are places on Earth where the sun is occasionally directly overhead, and it's between 23.5 degrees north latitude and 23.5 degrees south latitude. And 23.5 degrees is the tilt of Earth's axis in our orbit. But if you go in that range, those are what we call the tropics. And there are days of the year where the sun is actually directly overhead. The general trend here is the farther away you are from the equator, the closer you are to the poles, the lower the noontime sun gets. So if in the tropics, it's occasionally directly overhead, as you inch your way out of the tropics, the noontime sun gets lower and lower and lower in the sky. So when you hit the Arctic Circle, there is a day where the sun never sets, and it stays that way throughout the summer. And then it drops back down to the horizon, and then it goes below the horizon for the winter months. And then it's not to be seen again till summertime. So now that makes an interesting fact. Let's go to the moon and go to the South Pole. As you approach the pole, the height of the sun above the horizon doesn't get very high, just like I described here on Earth. So the noontime sun in the South Pole of the moon is very low on the horizon. There are craters on the moon. Some craters are at the South Pole. Craters have rims that stick up a little bit above the terrain. Craters are deep. When the sun is up at the moon's south pole, it does not get high enough to peer above the rim of the crater. So the base of some craters at the lunar south pole never, ever see sunlight.
Among the myriad of lunar mysteries, the existence of cold traps stands out. Imagine a comet colliding with the moon. The aftermath isn't just rocky debris, but a cocktail of water and other ices. These icy remnants in the shadowy recesses of craters could potentially be the cold traps, holding secrets frozen in time.
If a comet hits the moon, the material is now not rock, it's like water and other ices, like ammonia ice and things. Let's focus on the water. The water molecules, there's a lot of energy there, it'll evaporate. The water molecule flies up and then falls back to the moon's surface. It falls to a part of the surface that's in sunlight, it'll eventually evaporate and escape. But suppose it happens to fall where the sun don't shine. It stays frozen. It's called a cold trap. That's the official term for it. And falls in there and it stays there for billions of years.
In this age of technological marvels, the horizon of lunar exploration is expanding at an unprecedented pace. Tyson paints a future where the moon isn't just a subject of wonder, but a bustling hub of scientific research, possibly even a launch pad for missions venturing deeper into the cosmos. The anticipation surrounding NASA's upcoming mission is palpable. Tyson underscores its significance, emphasizing its ambitious goal to touch down on the lunar South Pole and potentially validate the presence of water in the craters.
The next mission to the moon, Artemis, the one where we're going to land, Artemis 3, they're targeting the South Pole to land to check and verify that there's water there inside those craters. We not only think there is theoretically, we have some measurements that there's likely water there, and now we're going to go and verify for sure. Because if there is, you don't need to bring water to the moon to drink. It's what's called ISRU, In Situ Resource Utilization, which is a NASA thing. It'll be a geologically, chemically interesting next place to visit.
The South Pole, with its promise of unveiling age-old secrets, is a testament to the moon's enduring allure. The sun's low arc at the poles plays a pivotal role in shaping this narrative, adding layers to the moon's mystique. However, lunar expeditions are not without their perils. The absence of a lunar atmosphere leaves astronauts vulnerable to the sun's fierce radiation. Additionally, the moon's drastic temperature fluctuations present formidable challenges to both equipment and habitats. Yet, Tyson remains optimistic, championing human ingenuity and innovation as the keys to surmounting these obstacles. International space agencies, private enterprises, and academic institutions are coming together, pooling resources and expertise. In the coming years, as we venture back to the moon and perhaps beyond, guided by visionaries like Neil deGrasse Tyson, we are not just exploring celestial bodies. We are embarking on a journey of self-discovery, seeking to understand our place in the cosmos and, in the process, learning more about ourselves. The moon, with its age-old secrets and silent tales, awaits, ready to unveil its mysteries to those daring enough to seek them.